Now that you've gotten a bit of a taste for this, let's check in with someone who toils in the trenches of the real world. So I'm here at Mozilla with Steve Fink, and one of the topics that we cover in class is debugging or testing, making small, convenient test cases that are going to lead us to a bug or a defect in our program. That's tricky even for small classroom examples. It can be really difficult in the real world. Steve, have you run into problems like this in your job?
Sure. In fact, right now I'm dealing with a particular test program that went to a great deal of effort to kind of re-implement the algorithm that it's testing, which is great in terms of, comparing the C++ implementation and this JavaScript test program and giving you a yes/no answer. It works, it doesn't work. But if you actually do have a bug, it can be a bit of a pain tracking it down just because, okay, you have a failure somewhere in the test. Now you have to figure out what the test program is actually doing to figure out why it made the particular invocations into the C++ engine that resulted in the behavior that it's actually testing. So in many cases, it's actually easier just to have a brain-dead simple series of call this, call this, call this, call this, rather than for each of these items, call this if this is true and expect this output if this is where the reimplementation of the algorithm comes. Let me give a specific example. This was a test of typed array code, and if you access outside of the bounds of a typed array code, outside the bounds of a typed array, then it should give you a range error. An exception which of type range error. And so this test programs just went through an array of different possible inputs and then said, well, based on this logic, if this index is higher than this number, then expect a range error, otherwise expect this value that it pulled out of the array. So the actual test invocation right there is array element I should be retrieved from this typed array, and then you should get the result based on element J of this array. And it turns out, no, I didn't throw the right error, there was a problem. But figuring out, okay, so what exact element were you looking for, and what did you actually expect to find based on this other array was very indirect, very difficult. It would have been easier if it was just a dumb, simple series of statements saying, pull this element out, expect this error, pull this element out, expect this value. And in fact, that's kind of what I plan to do, is instrument the test case itself to generate a series of silly, stupid linear statements and generate a new test case out of that and then throw away the original, because as clever and as easy to modify as it is, it's not actually helpful when you're trying to track down a particular bug.
It's an excellent point. And one of the things we cover in class, you'll notice that in class, most of our test cases are relatively small and simple, and this is good advice. Sometimes it's better to have two test cases, one for each feature, than to try to combine them together and then have to tease apart an interaction later on.
Yeah. It also makes it much easier to do, for example, binary search. You can whack off half the test file if it is a very simple, straightforward test file. If it's all interrelated, then it's really hard to take off half at a time.
Exactly. We'll get a chance to see in class commenting out parts of a test file to see if it still causes an error. In a linear test file or just a sequence of assignments, that's much easier to do than if there's a lot of complicated control flow.